Hello everyone. Today we'll have the lesson of the basics of a logic circuit. First, I would like to ask you a question. So, what are the numbers our computer are dealing with?
0, 1.
0 is 1. Yes, very nice. So all the informations that our computers processing and storing are the zeros and ones, and we call them the bits. Now, this lesson is basically about how we will use these basic blocks to build a computer-like thing, our computers, to help us to calculate our functions, for example, the log functions. So, first thing, before we start to design our first logic circuit today, what I want you guys to learn is some basics of the Boolean algebra. The Boolean algebra is the algebra about the logical values, that is, the zeros and ones. So, there are three basic operations in the Boolean algebra.
Excuse me, sir.
Yeah?
What is the book? Can you write down it?
Boolean, that is.
Algebra. Okay, thanks.
So this algebra is created by a guy whose name is Boole. And this is all about how we're dealing with the logic numbers, zeros and ones. There are three basic operations. That's the addition, multiplication, and the negation. And there are also other derivative operations that we can use the combinations of these three operations to create that all that operations we want our computers to have. So basically, for the addition, that is, there are two inputs, x and y. The output is z, and 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. So you guys must feel a little bit weird. Why 1 plus 1 is 1, not 2? So I want to explain that this is just the definition of the Boolean algebra. So the Boolean algebra is a way that our computers to think. And we can use such operations to build our decimal numerical operations and our algebra system by hundreds or millions of such little bricks. And there are three representations of the operations. The first, you see, that is a table we call that is a truth table. The truth table is a relation straightforward showing the input and the output. The second hand is called the Boolean equations. And the third one, you see, this is a device. This is not a concept. We call it the logic gate. So what is a logic gate? It is just a device consisting of some resistance, transistors, and many other devices. Just a function like this equation. So you put x and y, you got the sum. And we call it an OR gate. So why this is OR gate? Because the output is 1 if and only if the input x is 1 or the y is 1 or both of them are 1s.
Oh.
So this is a multiplication. 0 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1. And this is the second expression, that is the equation z equals x times y. And third is the device. and we call it AND gate. So is there anyone who can tell me why we call it AND gate? Because we get the output 1 if and only if what?
Both are
Both
one.
of them are the same.
Both x and y are 1s. Great. And the third operation is negation. Just the negation of 0 is 1, negation of 1 is 0, and we call the device is a NOT gate. So you can see this truth table for this multiplication. We can see when x is 0, the output y is always 0. So the AND gate has a function that is the switch. If you assign this x as a switch and you put a 0 into it, and the output always be 0. So it is like you shut the light. You turn the light off. And when the switch is 1, and you can get the output exactly same as the value of y. X is 1 and y is 1. The output is 1. Y is 0. The output is 0. Are you clear about this? Yeah.
What about the numbers in the middle?
Those numbers, these are the output, is z in the truth table.
Oh.
These are input values x is 0, 1. Okay, now let's design our first logic circuit. So let's have z equals a times d 0 plus a negation times d1. So anybody can tell me how many AND gates we need to have? Now AND means multiplication, so we have 2 AND gates, right? And how many OR gates we need to have?
One.
Yes, 1. And how many NOT gates we need to have?
One.
Yes, correct. And we connect them like this.